Okay, guys, I'm going to try to help you on a few assignment problems for section 2.2. So first, you see the first three questions are really similar, where you have a chart and you're trying to fill in values. Remember, the whole idea is that you cannot plug 0 or whatever number they're talking about, the limit approaching, like x is approaching 0. I can't plug 0 into this because you will get a number over 0 or sometimes 0 over 0. And that means, oh, you're going to explore it some more. Okay, so you're going to plug this into y1, and then you're going to plug in these values into your chart and see what you get. I'm just going to demo one of these, and I'm going to demo the one down here, because whenever we type this into our calculator, you got to be really careful. So whenever we type this into y equals, when you have a fraction, you have to do the work of this automatically groups the top and the bottom. So you want to make sure you type in x cubed plus 64 parentheses divided by parentheses x plus 4. Because if you type in this x cubed plus 64 divided by x plus 4, you're going to get something completely different because it's going to do this first. Please excuse my dear Aunt Sally, PEMDAS. So you don't want to do that. You want to make sure that you group them. So I'm going to go ahead and demo this one. So x cubed plus 64 over x plus 4. So let's go to the calculator view. So we have x cubed x, oh, what did I forget to do? Parentheses, x cubed plus 64 divided by x plus 4. And remember, you go to second and then you hit window, which is table set, and you change this independent variable to ask. Then you go to your table and you type in whatever they said to type in. So in this case, we're typing in negative 4.1. And we get something. And then I'm going to type in negative 4.01. And then I type in negative 4.001. So I'm getting closer and closer and closer to negative 4 without actually equaling negative 4. But even it showed that as negative 4, even though it's not technically. And you got to check both sides because you need to make sure that the limit from the left and the limit from the right are the same. And so you see that what number are they closing in on? Hopefully you can tell that the number is getting close to 48. So for this problem, the answer would be 48. Now yours is going to be different than that because they're all randomly generated. So this one, you would fill in all these values and the answer here is 48 because that's what, as x, remember this means as x gets close to negative 4, what does this function get close to? Does not mean it equals, it means it approaches 48 because there's actually a hole there. So that's that one. Now let's look at the next one. We see this piecewise function, x squared minus 1, and then it says x and then negative 1 when x is equal to 1. So basically you have a hole and then they plugged in that hole with this value here. Use the graph to find the limit below if it exists. So the limit as x goes to 1. That means as we approach 1 from either side, what am I approaching? So here I am, here's 1, I get on the function, I come close to 1 from the left, I come close to 1 from the right. I'm approaching this open circle, which is a y value of 0. So that one would be 0 for my particular question. This one, they told you this is the graph of absolute value of x minus 4 over x minus 4. You can see there's a jump here. Does the limit exist? The answer is no, because as you come from the left and as you come from the right, do my fingers go to the same spot or are they going to different spots? Different parts, different spots. So they don't match up. So that means the limit doesn't exist. A jump in the graph means the limit doesn't exist. So for this one, we would write D and E because D and E stands for does not exist. So there's that. Here's another graph tangent as we go to pi over 2. So we get close to pi over 2 from the left and the right. Now notice there's this asymptote here. There's a big asymptote. So this thing right here means we're going to positive or negative infinity on either side of it. So here we are, here's pi over 2. As I come from the left, I'm going up to positive infinity. As I go from the right, I'm going down to negative infinity. So the answer is does not exist, because if you remember, there's 3 times that a limit doesn't exist. Jump, oscillates, and if you're going to infinity. So D and E is the answer for that one as well. Okay, and now we're gonna find some values. So what is f of 1? F of 1 is the y value at 1. So I notice here I am at 1, and I'm not gonna pick these open circles. I'm gonna pick the actual output, which is 4. Now the limit as x grows to 1, in this case, the limit does not exist because your limit is coming from the left and from the right, so you do not exist. I'm going to let you do f of 5 and the limit of f of 5, see if you can get that one. We have another graph with similar ideas here. So as I go, what is f of negative 2? There is no dot at negative 2, so f of negative 2 doesn't exist. But the limit as x goes to negative 2 also doesn't exist because we're going to positive and negative infinity. F of 0, again, when you're finding the value of the function, f of 0 means the closed circle, so that would be 5. Whereas the limit is what you're approaching, but this in case I'm approaching 2 different things. There's a jump, so the limit doesn't exist. Whereas here at 2, the limit would exist because even though the function's value isn't defined at 2, the limit is, it would be 0.5. It's halfway in between 0 and 1. And you see that both from the left and the right are approaching the same open circle. So that value, that limit would be 0.5. So there's a few of those demoed for you. So this one says, for which values does f of x approach a different number from the right than from the left? So basically, where is there a jump in the graph? And on this example, the jump, when you see different from the left and from the right, what that looks like is a jump. And where do we see the jump? We see the jump here at -3. For which values of f of x increase or decrease without bound? This would be going up or down to positive or negative infinity. And in our graph, that does not happen. So we would say none of these. For which values of c does f of x oscillate? You don't see that crazy oscillation like we did in the lecture for this one. Identify the values of c for which the limit does not exist. So in this case, there's only one, and that would be at the jump at -3. Which values does it approach a different number? So where's their jump in this graph? You're looking through from your left to your right. Where is their jump? And that would be at here at x equals 0. So that would be 0. Which values does it increase or decrease without bound? Here it's -2. There's not arrows here, but there should be. And there's no places that it oscillates. Where does the limit not exist? It doesn't exist at -2 because we're going to infinity and at 0. And then the limit as x goes to -1. At -1, this one, even though the graph itself is a wave, it's not, I can zoom in close enough to figure out what it is. At -1, it's right here. And what is that y value? That value is 0. So when it's oscillating, what that means is if you zoom in and zoom in, zoom in, it's literally just such a blur, you can't see where it's going. That's different than a wave like this, where you can zoom in and see the y value. So that's an important distinction. The limit doesn't exist here. Use a graph to find the limit because as we go to -2, we're going 2 different places. We're going to positive and negative infinity, so it doesn't exist. So hopefully that will get you through your assignment 2.2. If you have any questions, please email me.